Hello.
Hello.
Just want to quickly check. This is TAG-Runtime, right?
It is, yeah.
Amazing, brilliant. I know that was it last time that there was oh yeah, there's Ricardo. I had to join a different meeting link. It was wasn't the same one that was on the calendar. Hi, Ricardo.
Hey, Alex. Morning.
Good morning. Yes, it's evening here. It's 5 o'clock here.
Oh yeah, evening.
No worries, no worries.
Where are you in? Are you in Germany or?
Yeah, I'm back in Germany now.
What part of Germany are you in?
South of Frankfurt now, or south of Frankfurt.
Okay.
Heidelberg.
Oh, okay. It's a college town. Yeah.
Yeah, exactly. Yeah.
Yeah. Okay, let's give it a couple more minutes. Maybe some more folks decide to join. All right, we can get started. Today we have Derek McGowan from the Containerd project. He's one of the maintainers, and he's going to give us an update on the project. Thanks for joining, Derek.
All right, sounds good.
Thanks.
Let me update the attendance log here first. Okay. All right, is it good? Is it sharing?
Yep.
All right, so if you came to the update at KubeCon, it'll be some of the same content, but gonna kind of talk about focusing more on kind of the updates to Containerd, less on kind of the architecture deep dive into Containerd itself, but more where Containerd is fitting in the ecosystem today. So right now we have 3 release branches that we're supporting. So we have the 1.5 release, which was due to be expire back in October, but we actually extended it through January 2023. A lot of these decisions are made based on kind of the reality of what people are are using and what the community needs. So we're pretty flexible. We don't have like a really hard limit in terms of like, we're going to support the release for this long, and after this time, like it's dead no matter what. We tend to extend stuff. And in that same light, the 1.6 release, we're making our first LTS release, which we're going to support for at least up to 3 years. So we announced this back around the KubeCon time. But some of the motivation behind this as well is because, yeah, we have a lot of users on 1.6, and we know a lot of them probably don't want to update for a while, but we're also wanting to free ourselves up to work on some new features and changes in the project. Like the project's, it's like not too old, but say even just like 5 years of technical decisions that we've been making. We have a lot of deprecated features that we've been working on, and there's also like new interfaces we want to add that we're trying to add starting in the 1.7 release. So we have the beta for 1.7, which was just released last month. We're going to be continuing the pre-release series for probably the next few months until we have the 1.7 final. So if you look at kind of our overall release, we have this in our releases.md on the Containerd main project. So anybody can go in and look and see when something was released. You can see the average lifespan of our release branches, as well as how long, like we're pushing 1.6 out to 2025, which just seems kind of crazy at this point. Like that we're even talking about like mid 2020s, but like that's what we're looking at in terms of support. So we're hoping that helps give some of our users confidence that don't like to update as frequently as, say, Kubernetes users are kind of used to. Some users will update Kubernetes much more frequently than Containerd even. So I'm going to give kind of an overview of different areas. Kind of how I view Containerd is kind of more of a resource manager in Glue rather than a particular runtime. I know we talk about runtimes a lot, but Containerd itself, like what's actually inside of Containerd, there's not a lot of runtime stuff. Like most of the stuff, runtime aspects that people associate with containers is mostly run C or Kata containers or gvisor or Firecracker, all these other projects that actually do the low-level containerization. Containerd kind of manages all of that and manages all the resources, has the common API that the clients connect to, has a series of plugins and ways in order to fetch all that container information. So I'm going to kind of go around this ring, if you will, to go through where we have updates in different areas. So we'll start with the clients. Kubernetes and Docker, definitely the most known, but we'll also talk about nerdctl a little bit, which is one of our own projects. So if you follow Docker and what's been going on, historically Docker used Containerd as kind of the runtime resource management only. It hasn't really used Containerd image store or snapshotters. And because of that, it hasn't really been able to fully integrate with Containerd and all the tools that are built on top of Containerd. So you could think of lazy loading snapshotters and all that kind of thing. Wasn't really able to be used in Docker, mostly because the backends were just incompatible the way Docker pulled down containers and managed them. The storage just wasn't compatible, and it's hard to switch some users when a lot of people have their pet containers and stuff. It was always kind of a challenge with Docker, but yeah, they're working on that now to have a more tighter integration with Containerd. And even in the Docker desktop today, I think there's an option you can go in and actually turn that on. So nerdctl is the Docker-like client that we actually have under the Containerd namespace today. It's only focused on kind of the CLI aspect. So it's it's pretty featureful, and it's kind of the place in Containerd where all of those little features that, oh, I wish Containerd could do this. Like it demonstrates like the full capabilities of Containerd, and it's kind of awesome because it really uses like every little feature that Containerd has. It kind of shows like its full potential. So if you go in there and there's every little thing you can think of, from rootless to lazy polling to encrypted containers to peer-to-peer distribution, like everything, like nerdctl has like gone there and played with it. It's really like the nerdiest possible client, I guess. It just like does everything. So it's a great place to go in and experiment.
I have a question about Docker. So they're integrating more closely with Containerd. Does that mean that they're moving more towards being a client like nerdctl, or they're doing other things, or they're just?
I mean, I don't know what their plan is in terms of like Docker's focus. I think has been more on the Docker desktop and like developers, and trying to focus less on kind of the Docker as like the backend. That's just like my observation. I don't work there anymore, so I can't really comment too much on like what exactly the direction is, but just from where I've seen some of this stuff landing, focusing a lot on the Docker desktop app. I mean, I think it makes sense. But in terms of like Docker versus like nerdctl, I don't think they really compete that much. And in a world where Docker is using Containerd more integrated, you could probably use both of them side by side. So if there's a feature that nerdctl has that Docker doesn't, if they're sharing Containerd as the backend, then you should be able to use both clients. At least that's what I would hope to see there.
Got it. Is there a requirement, version requirement for nerdctl to have a specific Containerd version, or it works with most Containerd versions?
Yeah, not right now. There's not a lot. Like Containerd moves pretty slow in terms of API changes. So there's certainly some stuff we're adding in 1.7 that could be a requirement to use it in nerdctl. But like if you're on 1.5 versus 1.6, I'm not sure that there would be much difference. Like nerdctl implements a lot of this stuff directly using Containerd's APIs, and those APIs don't shift very much from release to release. And 1.7 is kind of one of the first releases we're adding new APIs, like high-level APIs, which I'll get to later in this presentation as well. But
sounds good. Got it. Thanks.
And then of course we have Kubernetes kubelet as the other major client of Containerd. And obviously there was some big news in the last year that's pushed a lot of usage onto Containerd, but it's also increased a lot of contribution. It says here the 100% between 2020 and 2022. If I pull up dev stats, I think it's reflected in a lot of the different stats that show up, from like PRs open to issues. Like it's created a lot more activity on the project, which is good, but it's definitely hard to scale even at a project of our size. So we don't always scale the number of reviewers and maintainers and stuff at the same rate that contributions come up, but it's definitely good to see just the number of increased usage of Containerd kind of across the board from this change. So on the same vein, there's still a lot of ongoing work going on upstream in CRI and SIG-Node, but also changes we're trying to pull those down into Containerd. So CRI is kind of an ever-living interface. I don't know how to say it. Like it still has a lot of changes going on in it, and a lot of features that are kind of pushed through Kubernetes. A lot of them require CRI changes or little updates. And that creates a little bit of a challenge for us since, you know, as you saw, like our support timeframes are a little bit longer. Like Kubernetes actually does releases much more frequently than us. So when CRI makes changes in a Kubernetes release, we might not always have a release for Containerd right away. But we have tried to commit to add features to Containerd as quickly as we can, even talking about backporting specific CRI changes into our supported releases. So 1.6 is having an LTS release brings up that question quite a bit for how are we going to continue to support CRI in a long-term support environment where, you know, Kubernetes 2 years from now might look, its API might have a lot of new features or a lot of new things that we don't necessarily have in Containerd. Luckily, most of the stuff that's added, it's not really like, oh shoot, we have to go add some significant new feature in Containerd. A lot of it is like, oh, we just need this new API endpoint, or like it's functionality that's already possible in Containerd. It's just being exposed to CRI in a different way for most of the features that we come across. So they're not, it's not like a huge maintenance burden, but that's one thing we're committed to for the 1.6 release is to keep that flow of CRI changes going back into the LTS so that LTS users can continue to update Kubernetes without having any sort of incompatibilities at the CRI layer. So we have examples of some of the other features that are being added to CRI. So we have like the user namespace support, and user namespaces are a feature where the underlying file system ownership kind of matches inside of the container, which is pretty tricky from the mapping of users back to the actual host file system. So think of it as whatever the user ID inside the container is doesn't necessarily match the user ID outside of the container. So when you actually go to map these, there's some complicated logic that sometimes has to happen to manage that. So we're trying to add some support there to match whatever is being supported upstream in Kubernetes. User namespace is actually something we've had supported in Containerd for almost the beginning. It's probably about 5 years. So this is, I guess, kind of one of the examples of something being added in Kubernetes and CRI that Containerd does have support for, but we just need to support the API that Kubernetes is expecting there. Same kind of goes for the checkpoint restore stuff that we've had in Containerd for a while, but once it gets exposed in Kubernetes, it might be a little bit different. So let's move on to talk about kind of the plugins and our plugin landscape today. So one of the buzziest ones has been lazy loading snapshotters, and I think for good reason. It's common. It's a common measurement to know how long does it take from a container is being scheduled on a node to actually like there's this container is up and running. And one of the longest polls and all of that is always polling the container. Since we actually pull down all the resources from the registry, and now all those resources have to be unpacked, and then the actual process can be started. Most of the time, the actual starting of the process, doing the mounts, setting up the namespaces, starting up the process is pretty fast. So we end up looking at the polling or the actual poll taking up 90-something% of the startup time. So lazy loading snapshotters is kind of interesting from that aspect because it prevents or it minimizes the time that's blocking between a container being scheduled and actually starting up. And most of the time, containers don't necessarily need the full file system underneath them. So the lazy loading snapshotters allows that process to either happen in the background or to happen as needed. So there's a few different projects that we've kind of accepted as non-core, or even stuff that's might come in as non-core. So StarGZ one is the one that's been around for a while. It makes use of the formatting of the tar to actually allow kind of range lookup of specific files directly from the registry, rather than having to pull down the entire tar at once. Nidus is a project that came in from Alibaba. They have a few, there's a couple projects in Containerd to support that. You'll see there's this overlay block device that is kind of a different way of doing the underlying file system. And then we have the Sochi project. Is that how you say it? Sochi, the SQL OCI. I'm not sure I'm pronouncing it correctly, from AWS. Not sure if this one's going to come in as a non-core subproject, but it's another one of those interesting snapshotter projects here. And let me go back to this one for a second. Just talking about, I mentioned a lot about the non-core projects, and we've kind of opened up our namespace a little bit to projects that are very tightly related to Containerd, but they need some ownership. So we just differentiate them because the non-core projects will have their own set of maintainers and their own release cadence and everything. So it's almost like a incubator for specific repos that are related to Containerd, but it's been pretty successful in terms of giving some of these projects the visibility and home they need to make it into the Containerd ecosystem and thrive a little bit. But yeah, especially for snapshotters, it's been a great place to have some of these plugins come in through that. So NRI is another plugin interface we've been working on. There was an initial version of NRI that came in maybe a year or 2 years ago. It's similar to CNI, but it's, instead of focusing on setting up the network namespaces, it's for setting up resources, device resources. You could think such as any sort of block devices or GPUs. Like there's a long pull of devices that need to be added to a container, but also have to be managed directly from the host. So you could have specific resources that are kind of custom and specific to that host that you want to be able to request and manage, that wouldn't necessarily be managed by Kubernetes today, or managed by in the same way that some of the other like stuff is managed natively today. So it adds that pluggable interface so that we can add these sort of resources and expose them back through Kubernetes so that they can be managed like normal resources here. So I don't know how to describe exactly what I'd say the first version of NRI here was very similar to CNI. It was using the same plugin approach where you have these binaries that you call out to, and each of those binaries is this short-lived. You pass along a JSON structure. CNI has its limitations because of that, and execing out every time you start a container isn't necessarily the most performant approach. It leads to some complications around like how do you actually manage these resources that are, or if you have, say, a shared pool of resources, now you have a bunch of separate processes trying to call into it. You have locking contention, or you have, if you're just using the file system, sometimes you have some complication in terms of consistency there. So NRI that was kind of the first version of NRI. We're trying to add a newer version, which is more using something similar to, or like how we do with the shims, where we actually have a single plugin instance that can be connected to via gRPC. It allows the plugins to manage their state a little easier, hopefully add a little bit more stability and reliability. Some stuff that we've had some problems with CNI, but so it's that new approach, and the API will look like we have an OCI spec coming in. It'll go to the NRI plugins, and the NRI plugins are actually able to make changes to those OCI specs. So these are the actual runtime specs that get passed to the low-level container. So these can add any sort of device. So if NRI, when you create the NRI request, it could say, create a new device for you, and then add that device to your OCI spec so that the container can make use of it.
Alex has a question.
Yeah, go ahead.
Perhaps could you go into a little more detail about what you mean about tracking the state of changes to sandbox things like micro VMs?
Tracking a set of changes to micro VMs from the NRI perspective?
I'm trying to understand the context of NRI with regard to what you've written on the slide that says micro VMs.
Oh, gotcha. Let me remember the context of this slide. It said some of these slides were from the presentation from KubeCon.
Yeah, no worries. So I can see this interface actually being super useful in a number of different contexts. I come from Unicraft community. We build unique kernels, and one of the tools that we build is an integration that makes it possible to run lightweight virtual machines through actually what's a container D shim layer that basically changes the runtime, right? So you just change the runtime, and then instead of launching a container in the usual fashion through container D, it actually launches through whatever virtual machine monitor, whether that's QEMU or Firecracker, etc. And the NRI system makes a lot of sense in the context of launching a virtual machine, right? Because at this point you're interested, for example, in mounting particular types of disks, which might be on natively on the host, right? Imagine a service like you're like serving just files through a web server like Nginx or something, and you've got like auto index enabled, and you just want to like serve all the files inside of some sort of HTTP protocol, and you can expose that through a unikernel, right? If it mounts to a particular disk, and then the integration that would come as a result would be interfacing directly with the NRI. I'm not sure if the NRI, how it's implemented, whether it itself is, so I can see, this NRI.sock, so you could interact with it. This way, you would expose, for example, the list of disks or whatever other services that you might have that are attached to the node, as far as I understand. So, it could be like iSCSI, it could be like a mounted partition, if I'm understanding this correctly.
Yeah, so yeah, we'll have the socket for being able to be interacted with. I'm not sure if the intent here is that the sandboxes necessarily would directly talk to NRI, but the NRI plugins themselves, since they can hold state, unlike say a CNI plugin, they can track these resources and as they mutate over time. So I think that's like one of the abilities here that's not necessarily what we think of with CNI. Like CNI doesn't necessarily sit there and listen for changes, although some plugins do. I mean, I've seen like CNI plugins, or I don't think it's too uncommon of a pattern of the CNI plugin just be an instance of something that connects to another instance, or connects to like a single state instance, that actually can track all that information. But yeah, I think for NRI, yeah, it's definitely going to make sense for cases like what you're saying, where it's tracking those. And maybe, like, I don't know if this NRI sock is really intended for kind of other processes to come in and make changes there, but that may be possible.
Okay. The other question I have is, I see there's sort of these balloons that talk about initial OCI spec, adjusted OCI spec. Will the OCI spec itself be adjusted in some fashion to be able to make reference to the NRI? Like, for example, declaring, I need this, I don't know, resource that's on the host. Will that be part of the OCI spec, or is this abstract to that? And then it's just container D that's saying, okay, I'm going to access this because this is what the configuration said on the host. I'm just trying to understand the OCI part of the interface here.
I mean, this is just making changes. It's hard to define what that represents. It's that JSON, it's that actual JSON spec that's going to get passed through. Like, it's not, I don't think that there's specific changes to say what we would need in the upstream spec, but like, there's anything that's in the spec today, that JSON objects getting passed down, it can make more, it's more flexible in terms of what it can change there. I guess that's mostly what it's trying to define here. So anything that's in the OCI spec could be adjusted here, whereas before there was, I think, like CDI and some of the other changes that were actually making changes to the OCI spec were more targeted in that, like, oh, you could add a device and the device was this part of the OCI spec, you can make this change.
Yeah, exactly. This is the kind of, I was trying to understand if this was would make its way, I don't know if it would be part of this, the OCI image spec, or whether you'd be able to say, look, I can even imagine a plugin, for example, that would provision a physical resource, right? Yeah. Or that could format a physical resource, right? Where you might say, like, look, I want an ext4 partition, and then the plugin would, enable the partition for you, and then you would get the properties of an ext4 partition, which might be, it could be default for Linux, but imagine, if you have a system that's running containers on Windows, you might want a fat partition, right?
Yeah, I see what you're saying. I don't think that at least the OCI, that object is going to be used as kind of an API object for passing in data. Like, you'll still be able to pass in kind of that resource information, say from the pod spec, and make use of that at the NRI level. So you don't necessarily need to use that object to pass in specific, like host specific information or something like that, from the initial OCI spec. But
yeah, sure. I guess it should always kind of be abstract to the specificness of the host, because you could be provisioned on whatever, right? And it might not have the same properties, but at least being able to, this is kind of a detour, being able to specify some requirements of the resource might be interesting, but I don't know if that's the target of NRI. Like, it's clear that NRI is abstracting, making it easier to interface with some resources, particularly things that are coming through, for example, Linux, right, where you can see from the README on the NRI repo that is talking about, for example, things that are available in proc.
Yeah. I want to say that the input here from the pod spec perspective is more related to which resources should be owned by this particular instance, rather than how to provision such resources, like the NRI plugins would own that. Yeah, but I'm not sure like what you're saying in terms of, or what that interface is in terms of using the context from the pod spec to make those decisions. And NRI is one of these, some of the updates I'm talking about are work in progress. I'm not sure if you're involved with NRI today, and the, like, this isn't even merged in. We want to get this into 1.7, but it's still a work in progress.
No, sure. I mean, this is actually totally the first time I heard about NRI is through this.
Yeah, you should take a look. Like if this is interests you, there is the initial version of NRI. That's the CNI one, but the one that Christian's been working on for a while. It's this new approach of having this NRI socket. All right, I'll move on to next.
Derek, one small question, or the NRI plugins, you don't have any right now, or these, or do you have any that are doing something specific?
There are NRI plugins for the kind of the initial version. There's some base ones. There's some ones for managing like CPUs and GPUs. So like managing like the NUMA cores and stuff like that. There's a few of those plugins. I'm not quite sure, like the plugin ecosystem around it hasn't exploded because it's been kind of new. We're hoping that this new version will prompt like a wider range of plugins. It's much more flexible, as well as saying about how to like its capability set, I guess.
Yeah, sounds good. So I mean, it looks like it's going to be very extensible, which is great. So,
yeah, I think we had an NRI session in TAG-Runtime a few years ago.
Yeah.
So it should add to the capability set there. But yeah, we're making changes, or trying to make some changes in terms of what that actual API is to make it a little bit more flexible.
Makes sense.
I'm not gonna spend too much time talking about Rust, but following the trend of having plugins and libraries in Rust. I mean, it certainly makes sense from where a lot of the low-level runtimes are going. We're seeing more and more of these low-level runtimes being implemented down in Rust. So from a plugin perspective, it makes a lot of sense, especially considering like for containerd itself, like the Go, I think still works pretty well. But when we start talking about, various different plugin processes and shim instances, things like the runtime overhead of Go become more of a conversation piece. We're not talking about a single instance, but now we're talking about multiple instances of these shims and plugins and the whole Rust ecosystem being built up around it. So likewise, we have more extension points, libraries that we're adding in containerd in order to actually use Rust. Yeah, especially at the shim layer, but just having full gRPC clients allow us to make use of various different plugins, or use various different like Rust plugins, since we heavily rely on gRPC for our plugin interfaces as well. So let's talk a little bit more about runtimes and kind of what's going on there. So kind of the big thing that's coming in 1.7 is this new sandbox API. Somewhat related to what we were talking about with NRI, the sandbox API is a new interface for actually controlling the sandbox lifecycle. So you can think of changes to the actual VM that may become relevant over time, from resizing the VM to just when that VM actually gets started up and how long it lives, and what's the relationship between the different containers that run. The sandbox controller is a is an interface that's more designed to manage that life cycle rather than previously these were managed through the task API, which was focused more on an individual container lifecycle. So stitching them together was kind of hacky in some ways for the VM case. So
I agree on this. Having done that exactly, yes.
yeah, exactly. Yeah, anybody who's had to play around with that, you see, it's yeah, you have things like the pods container, which is a hack in Kubernetes that's kind of been there from day one to simulate having an actual sandbox environment. So this negates some of the need for having the pause container at all. So eventually we should see the pause container kind of go away and or at least let it be owned by the actual shim, have it be behind that sandbox API, so that the pods container is just an implementation detail of a specific shim rather than a requirement in order to run a pod. And yeah, this interface is going all the way up from the shim all the way to CRI for how it's being used. So there's been ongoing CRI integration. If you look in main, you actually see there's work to create a new backend. It's a whole new server backend for CRI using the sandbox. And right now you can use this new backend in 1.7. Will be the default in 2.0. It should be completely invisible to the end users. But we want to get that in and try to get that stable for the 1.7 release. So you can try it out. And, if you're implementing something that needs to use this or wants to make use of this new features, you can do that. 1.7.
Inside the SB server, sorry, subdirectory. I'm just trying to find exactly where I can grab my hands on it.
Yeah, the SB server is, I think there's a server and then SB server is the sandbox server. So the server is kind of like, yeah, it's like the CRI back. It's the backend for the CRI plugin in Containerd, and it was basically forked into SB server and server.
Okay, cool.
So we're kind of maintaining two versions of the backend for now until 2.0, in which time we'll kind of cut off the old backend.
If I think about you're supporting naturally multiple different versions of Containerd. Would this, implementing a runtime, for example, based on this idea and implementation, it wouldn't be backwards compatible with, for example, 1.6?
Not if it's using the sandbox API.
Okay. So the pod sandbox API.
Yeah. So we're looking at backwards compatibility in that the existing shims continue to work. But I think what you mentioned would be more like forward compatibility, where like new stuff working in like old versions, which wouldn't really be the case.
No, but I mean, if you implemented, say, something based on this sandbox SB server API, right? Whether you'd be able to launch something through your own, for example, Containerd one-time implementation, whether it still work given a previous version of Containerd, right? Given that it's its own individual binary.
Gotcha. Yeah, the older version of Containerd wouldn't work because it's a new API essentially. So
okay, yeah.
This is
gRPC, right, or HT.
It's using the TTRPC.
That's one, TTRPC. Yeah, that's right.
Yeah, I mean it's the same thing as we've had actually a few different versions of the shims over the years. We've had, I think we're on kind of the shim version 2 already, and then there was like almost like a 2.1 to support having a single shim instance for a pod. So the shims have evolved over the years. We've maintained support for the older shim formats in the new releases, but yeah, obviously can't go the other way. Like you can't implement the new API and then have the old one support it. And this isn't,
Sure.
this is a pretty large change that we're not going to backport to 1.6.
Okay. Yeah, I guess it makes sense, considering it's speaking over this protocol at the same time. So yeah, I'm just thinking about but the lifecycle is going to remain very similar though, regardless of whether you're making structural changes into the CRA pod sandbox implementation, right? You think about the lifecycle of a container, for instance, in a Kubernetes cluster, it's still going to have that same set of actions that are necessary to be applied onto it. Whether it's create and status, and the think about the full interface there. That's still going to be the same. I guess just the communication mechanism and I guess the relevant arguments are also changing. Or is it truly the way that you do sandboxes? Is it something that's going to be necessary to change upstream in terms of going up the way to a new version of Kubernetes, for example? And I mean, of course, they release faster, so they're able to incorporate this change. But is it at that level?
No, it's more focusing on what's below containerd. So it's focusing more on the Kata use cases and micro VM use cases rather than above. There shouldn't be. I mean, it might enable some more configuration you could potentially define in your pod. For example, you can think of being able to make changes to the actual sandbox environment of a running instance that you couldn't necessarily do. So it should enable new features going up, but it doesn't require, if that makes sense. So it's kind of like it opens the toolbox at the low level, but you don't have to make changes in Kubernetes to make use of it. And for the most part, yeah, most features, I think, don't necessarily need to get bubbled up all the way through Kubernetes, but I mean, there's always new features coming in from the Kubernetes side anyways.
I feel like there's so many features, it's hard to keep
yeah,
up,
exactly.
Question, so the CRI, or from the CRI perspective, this will be compatible with any kubelet version, or?
Yeah, so this is the back end of CRI. So there's no changes to CRI. Right? I don't even know if there's any changes to like the API handler. It's completely on the back end side right now.
Got it. If there were going to be any changes on the CRI spec, then this will have to be, changed too, right? So.
Yeah, it's mostly looking down right now, so it doesn't have to go back and need any like CRI changes in order to handle it.
Got it. Cool.
As I said, for the most part, it should be invisible to users. I think the users that will find the most use out of it are going to be mostly micro VM users who are basically want some of these features. All right, let me talk about the shim plugins. It's quickly. It's somewhat related. It's we added in 1.6 a new pluggable, or it's adding to our interface the ability to add more proto services. So traditionally, the shim API has been a single proto task service. The sandbox API now has two services. We have the existing task service, but we also have like a shim service for managing the actual sandbox environment. So we've added the ability to add services, but there's not. We can continue to add more than just say the existing sandbox service and the task service. It's now more extensible to anything, essentially, any sort of service that you want to do inside of the shim. We don't want to go too crazy in terms of saying, like, oh, you should do all this in the shim, because the shim is still intended to be pretty tightly scoped. At least that's what we hope. I mean, you could do something crazy like containerd and containerd, have the whole API or something if you want to go like go full crazy there, but like we're not at that point. But what we are seeing is these use cases coming from confidential computing, wanting to actually do distribution inside of the sandbox. They don't want the host being able to look at anything related to the container image. So it wants to be able to do all the snapshotting, all the management completely inside the guest, so that the host not only can't tamper with it, but can't even see what's inside of it. So that's an important use case here, and where having these plugins actually makes that easier to extend the shim. Whereas previously, like the only way to do that was to say extend the existing task API. Same for the port forwarding use case. Most of port forwarding that's done today is for debugging primarily, but it's very kind of Linux centric, or it's very tied to what the host capabilities are today. So for the VM environment, there's not a good way to do port forwarding. So this will allow us to actually have the shim be able to do that port forwarding for us by having essentially an interface that CRI could call into and say, hey, do the port forwarding. Whereas today, CRI tries to do the port forwarding today, making assumptions about essentially being a local namespace container running C. But as soon as you run Kata containers or gvisor or some of those others, it breaks down. I think Windows has a specific implementation for it as well, so it still works. But yeah, it still has the same problem with the VM use case. Not going to spend too much time on WASM, but there's been some announcements lately about the WASM-based runtimes. So there's this new Run WASI project, which says you should definitely use it in production. But I personally, I think WASI is kind of a really interesting case that's been kind of evolving over the last few years. It's nice to see it maturing a little bit, and to the point where we can actually make use of it as a runtime environment. And WASM is interesting because it's basically defined as a container workload from the beginning. Like, I mean, it's designed to run completely contained in sandbox. So it's interesting to see more of these use cases come in to Containerd as well. I'm going to briefly talk about distribution stuff since we're running out of time. But some of the stuff that's going on there, we have the OCI 1.1. So there was a working group that's been going on for like a year, kind of completed its work, and now we have a 1.1 draft specs. This defines a new refers API and distribution. So what this allows us to do is, so we have, say, images that are pushed to a registry. We can attach additional objects to those images. So the main interesting use case here being signatures and SBOMs that don't necessarily change the container, but they help validate or attest in order to that image in the registry. So the refers API allows you to go back and add these objects without necessarily changing them in a way to fetch them. There's also this new artifact manifest that was added because signatures and SBOMs aren't images or container images. They look a little differently. So there's a manifest that is designed to make it easier to differentiate these objects and define them. So from the Containerd perspective, it doesn't really change the flow in terms of how we pull images, but it gives us more opportunities to add plugins for, say, doing image validation, or having ways in order to fetch some of these objects and pass them to our plugins. So we're trying to support these APIs and make sure we support these new types, but we're still trying to go through the effort to figure out like what is the plugin interfaces to make use of them, because yeah, by default, like Containerd doesn't really have anything to do with them. Like it has all the, like Containerd has everything it needs to run, but we might want to be able to add stuff along the process to say, hey, don't run this unless it's signed, or some way to pass along this information to a plugin to make use of it. So I think Sochi, that lazy loading snapshotter, was an example of, they have objects that are essentially an index to help the lazy loading process find what they need. So be cases where plugins actually want to make use of this data, and we need to make sure that we have a way to fetch it through Containerd's APIs and make it available. And then the other thing that's been worked on in this space is we're adding a new service called the transfer service. Traditionally, when you do a pull from Containerd, we have a set of APIs, but those APIs are pretty low level. They're like, create this specific piece of content, unpack this specific piece of content, create this layer in order to unpack. So they're very low level. There was no like high level operation to say, hey, Containerd, just go pull this, or Containerd, go push this. All this was implemented inside of our Go client. Like all those operations that you use today are mostly inside the Go client, and then they're used, say, by NerdCuddle, which, you know, it gives some of those clients a lot of flexibility. The challenge here is, you know, if we go back to CRI, well, CRI itself, you know, does all of this stuff. So we have this kind of relationship where we have a fat client, we have a thin server, but then we have plugins that need that fat client. So it's kind of an illusion, I guess, that it makes Containerd smaller, because we still need all of this functionality in there. And it creates some challenges from a configuration standpoint. I want to have configurations for this registry, but now we have CRI has one configuration, we have NerdCuddle that's a different configuration, we have Docker which has another. So we have all these different implementations of things. So having a single service that can manage this stuff can manage all of the configurations, can manage kind of resource utilization, such as how many network requests are open and stuff in a single place, makes that a little easier. And it just creates a much easier API to do this stuff with. You don't necessarily need a full Containerd Go client to do this. You just need an instance of this service, which doesn't quite need as much as, say, a full Go, or as our Go client would need, like a full connection to all of the Containerd's APIs. So the API is pretty small, covers a range of different operations, though it's pretty flexible. But we're hoping that by having this central place, that'll give us a opportunity to continue to add extension points to Containerd for doing this image validation, credential logic, having your own like custom pull plugin, which today was kind of complicated. You couldn't really do it with CRI at all. You can only really do it if you had like a custom client. So this gives us the ability to continue to add extension points to Containerd. And this is actually my last slide. So we have more questions.
All right, we got a couple of minutes.
Yeah, I had sort of a tangential topic related to Containerd, but so there was an issue created. Let me find the link. In the Kubernetes repo, and as well as this came up in the TAG-Runtime mailing list about standardizing the unkill communication between container runtimes and the kubelet. There was some discussions about documentation. So there's a PR already open for the CRI API to fix some documentation. But the main point was that there is basically no way to determine from within the kubelet if a container was unkilled due to exceeding its configured limits or due to the system running low on memory. And one suggestion was to add a new dedicated field, something like reason, which can like help us figure this out. This is obviously non-trivial and might be even risky given the current implementations of all the different container runtimes, including Containerd. So I wanted to just like make sure this is on your radar, and also understand if you have like any suggestions on how we can move this discussion forward in Containerd and maybe even across other container runtime implementations.
Yeah, I think I've seen this one before. I think Mike Brown mostly owns a lot of these, especially like cross runtime compatibility stuff in CRI. If you feel like anything has stalled in Containerd, and I know sometimes it's kind of tricky here because we have like a 3-party between like Containerd, Signode, and like Cryo, and everything moves at its own pace. But I think from our perspective, adding changes, if it's specified to be clearer in CRI or added to CRI, that makes it clear what to do. Like there's still a lot of unspecified behavior between the runtimes in kubelet today that's kind of assumed, either inherited Dockerisms or just kind of some assumed behavior. So I would say a lot of it, I would say it's on the radar, but I'm not sure what the status of it is.
Okay, I'll also try to follow up. I was wondering if it makes sense maybe in the future to like bring Signode folks, Containerd folks, and Cryo, like all maintainers together, maybe a tag runtime call just to kind of brainstorm and take this forward. I just don't want the issue to die out.
Yeah, I think usually Signode is the best place, but yeah, there's definitely quite a few Containerd folks that go to Signode, but I think if there's a specific issue you're bringing to Signode that you think is relevant to Containerd, like definitely ping in like the Containerd or the Containerd Slack channel to say, hey, we're going to be discussing this topic that's related to Containerd and Signode, and generally, yeah, you can get some people to join if you ask, but I mean, it's kind of like the too many meetings thing going on, like between CNCF and, you know, we have a Containerd community meeting now, and then there's Signode and OCI. Like, I think finding the group that really owns it and then making sure that, you know, it's on the agenda and the right people know about it to attend. That's a common problem, which is, yeah, these meetings don't have the right people attending because most people don't just like attend weekly meetings, you know?
Yeah. Okay, that's helpful. Thank you.
Oh, it's a challenge.
It's hard, yeah, and yeah, I know that's been a challenge here. I tried to attend, but it's the same thing where it's like if it's relevant, it's easy to attend, but it's hard to get regular attendance in meetings.
Yeah, like too many meetings is too much overhead too, right? So you want to balance it out, right? So it's not.
Yeah, but I think what you're doing here, where you have an agenda and you advertise that agenda to make sure the right folks kind of come, I think is helpful. I mean, I don't attend Signode meetings regularly anymore, but I'm definitely willing to attend when there's a relevant topic that needs my input. Yeah.
All right, Derek, thank you very much. Yeah, let's keep in touch and yeah, see you around.
All right. Thank you, everybody.
Bye.
Thanks so much.